Hi, and welcome to another edition of Easy Theory. So today we're going to be talking about another application of recursion. And last time we were talking about mergesort. We're going to actually do another sort that is based on recursion, and it is called quicksort. So the idea here is it's kind of a mirror of what mergesort does, but done in almost the opposite way. So remember how mergesort works. We split the array into two pieces, sort the individual two pieces, and then we combine those two pieces together. Here what we're going to do is we're going to, again, split it into two pieces and recursively solve each of the two pieces. But instead of doing the merging after, we're going to now assume once we do the splitting that all of the elements are at least in some kind of order. So let's actually talk about this. So what does quicksort do? It sorts an array, as you might expect. So let's let A be an array. So I'm going to call this guy an array. So as this is a recursive algorithm, we need inductive cases and a base case. So again, what is the smallest possible array that we could be given? It could be one element or fewer. So if it is one element or fewer, it is already sorted, so we don't need to do anything. So all that we need to check is if the length of this array is at least 2, then we need to do some kind of sorting. So the first step here is if the length, let me do it this way, the length of A is at least 2, then we need to do some stuff. So the way that quicksort works is if you think about an array, let's just say that like we have the number 5 in an array somewhere. So 5 in here. And let's assume for the moment that this array is sorted. Let's just say in ascending order. Then we don't know, just by looking at this, what these elements are or what these elements are, but I do know what their value is because the array is sorted. What we can tell is that all of these elements on the left side are smaller or equal to 5, and all of the elements over here are going to be at least 5. Okay? And it can't be the case that something over here is bigger than 5 and something over here is smaller because the array is sorted. So what we will do here is, well, let's try to pick some element of this array and move all of the smaller elements to the left of that, wherever that element is, and all of the bigger elements of whatever we pick to the right side. So here, what we're going to do is we're going to pick what is called a pivot element. I'm going to call it P of A, of this array. Okay, so I'm just going to pick some element of this array. It does not matter which one you pick. We can pick one that's really bad, one that's really small, one that's really big, one that's in the middle. Does not matter. Let's just pick any one out of there. And what are we going to do with this? So what we're going to do is we're going to move all elements of A bigger than or equal to P to the right of P, I'll just say. To the right of P. And all elements of A that are smaller than or equal to P. Actually, what I should do is I'm going to take the equal sign off of one of the sides, because if we have a bunch of elements that are equal to P, then they could go either left or right, and I don't want to make any kind of confusion there. So let's just say that if they are equal to P, they go right. But since they're equal, it doesn't matter. So all elements that are strictly smaller than P to the left of P. Okay? And then all we need to do, because all of the elements that are smaller than p are over here, all I need to do is worry about this part individually, and then all of the elements on this side individually. So all we need to do is call quicksort on B, where B is a set of elements that are strictly smaller than P, and then we need to call quicksort of C. These are just names of the two halves of the arrays, where C is the set of elements that are at least P. Okay, so all that we're doing is saying that we're going to recursively work on this piece and then recursively work on this piece individually. So because all of the elements are in some sense in the right place, then all they need to do is the elements in this half need to move to some other place in this half. No element over here needs to move to the other side of this so-called pivot element. And same thing over here. If you have some element bigger than the pivot, then that element only needs to go to some place over here. It doesn't need to go all the way over here because it was shown to be bigger. And we want to sort this, let's just say, in ascending order. If you did a descending, the corresponding algorithm is very similar. Okay, so the thing that you should pay attention to is, well, this does sort the array, because if you have at least two elements, then you will pick a pivot element and you will move elements to the corresponding right or left side, and then recursively work on both pieces. Well, at some point you're going to go all the way down to the base case, which has an array of one element, or zero, and we know that an array of 1 or 0 elements is already sorted and we don't need to do anything. So we are moving elements to the corresponding side, which means that they are in the pseudo right order. They're not exactly in the right order yet, but they're placed closer to where they need to be. And as you get down to the base case, you will get closer and closer to where they actually need to be. So in the next video, we're going to do an actual example of this. But if you have any questions about this, put them in the comments down below. As always, please like and subscribe to the channel. It really helps us out. We have a bunch of links in the description for if you want to contribute further, such as our PayPal or a Patreon, or even our Discord server, where we have a bunch of discussions there. And as always, I'll see you next time.